Okay, this is Agential Topics, and I'm Charlie Munford. This is Wednesday, May 7th, and today we have a meeting about the search for epistolution. So, just for a little context, in this group, we've been deeply into the cognition first idea in biology for several months, and we did Perry Marshall and Steve Lehart and Richard Watson, and we talked about this idea, Mike Levin. So we've talked about this idea from a bunch of different angles, and coming up soon, we're going to kind of go down a different trail. We're going to go a little further afield. We're going to have Matt Siegel and Judith Rosen talking about Robert Rosen's work, Terrence Deacon, Kate Nave, and we're going to kind of go down this inactivism trail, which I think of as a different trail, and maybe we'll discover that it's all the same. But before we did that, I wanted to go ahead and go a little deeper into epistolution and the mission of Talking Octopus, which is the sponsor of official sponsor. There are many unofficial sponsors, but the official sponsor of this meeting. And yeah, so that's the purpose of today. And we're going to have a little dialogue between Josh and I that hopefully opens up some of what I think are the consequences of the cognition first point of view. So Dina's going to introduce it a little bit here.
Hi, all. Excited to talk to all of you. My name is Dina, and I work with Charlie and Josh to support Josh in bringing his ideas forward to everyone who needs to hear them.
Poor Charlie. Yeah.
So it's exciting for us to hear Charlie put his ideas out there today in front of all of you. I think many of you have heard bits and pieces, if not all of it, but I think that it's important to recontextualize why we're having this conversation. Hi, Mary, with everyone, why we're bringing this to you specifically today. So I think this entire group, let's start from a place of shared understanding. Everyone here, to some degree or another, feels there's something to biocognitivism. So we're somewhere on that spectrum, right? And I think what Charlie has done is he's asking the question, if there is something to biocognitivism to any degree, what are the implications of that? Not just downstream, but upstream. What are the systematic implications? And Charlie has pursued those rigorously, both downstream and upstream, and the result is epistolution. So what he's saying is, if we actually think that cognition, we're looking at an actual cognition first view of biology, then what does that mean? What does that mean for inheritance? What does that mean? Where does inheritance fit? And what is the motive force here? What's the mechanism? And can we bring some systematic thinking to biology, rather than biology's messy kind of anything, the rules are emergent and you can't really predict them, and it's not like physics. So what Charlie is saying is that so? In fact, it's not so. And what Charlie is saying is epistolution. And here we go. So that is where we're starting. And that is why we're talking to all of you. And what follows for now is going to be a conversation between Charlie and Josh. And Josh is gently going to litigate Charlie's idea. And hopefully you'll hear some of your burning questions represented in this 30-minute conversation. And if not, we hope that you bring them immediately after, so that we can really grow this circle of shared understanding and then figure out where more areas of inquiry are.
Totally. Awesome. Thanks, Dina. Fantastic. Fantastic. Okay. Yeah, Josh, you want to kick it off?
Yeah. So, Charlie and Dina and I have been talking about this meeting and these questions, and I want to try to just dig right into it. But, Charlie sent out this white paper, and I'm curious to know did people get a chance to look at it? It's pretty,
I
so
took-
maybe just a show of hands, if you at least got to, all right, so a lot of people did. That's good because I think it's makes a lot of strong claims and some controversial ones. So hopefully that's what we're going to be able to get into. Um, Charlie's white paper, and Charlie just himself, as anybody who knows him knows, makes the claim that a cognition first understanding of biology and evolution necessitates the acceptance of a set of other ideas, right? That what naturally flows from that, ineluctably, you might say, is a certain set of other concepts. So, and he calls that set of concepts epistolution. And among those are, first of all, that there must be a set of universal, and universal becomes an important word, a set of universal laws and a universal mechanism in biology that governs cognition. And also that these laws are going to explain what we see in adaptation better than a neo-Darwinian model does. One of the central claims that he makes is that the improving cognition is the primary sort of control parameter of life rather than survival. And that, because that goes so deep, I think that's a really good place for us to start. He also goes on to say that understanding the mechanism is going to solve things like strong AI, cancer, and allow us to manipulate biology in a lot of ways, practically without limit. So these are very, very strong claims. And while I think everybody in this room has a sense or a good feeling that cognition is somehow operating at these low levels in biology or primitive levels in biology, not everyone's on board with the full set of these ideas that Charlie calls epistolution. And it seems like a natural place to start is to ask, what's wrong with the neo-Darwinian model? And I don't think we have to spend a lot of time on that in this group, because I think people in this group already have a good sense of what are some of the problems with that model. But there are a couple of things that I think are worth highlighting, and I want to hear Charlie be able to talk about a little bit. And the first question, I guess, is why can't we understand cellular cognition as just merely a kind of control mechanism of the various DNA altering processes that we see? And why isn't it just some other form of information that exists in the cell that might be passed down, generation to generation? Why isn't it just simply that? And I think that's the first question I want to put to Charlie, but I also want to remind him about a kind of related topic, which is, how do we define genes? What are genes? And Dennis Noble makes a really good distinction between two different ways of understanding genes. And I think Charlie's actually adding a third way. And I'm hoping he'll elucidate that a little bit in his answer. But the basic question is, why can't we just see cognition as just another sort of source of information or some kind of process in the cell that we don't understand? Why does it have to be this driving force that underlies everything?
Okay. Yes. Big question. Thanks, Josh. So,
Yeah.
okay. Yeah, let me just first remind everyone why we think neo-Darwinism is not enough. So, the reason we think it's not enough, first of all, I think most of us would agree natural selection does happen, right? And that is important in like shaping what we see today as life. There's nothing incorrect about the concept of natural selection. But we think that we can reverse the whole theory because we don't know the sources of variation. Like that's the basic problem, is that the sources of variation are still not established, right? And so neo-Darwinism like in order for neo-Darwinism to be a complete explanation of life, the sources of variation have to be random. They at least have to be random with respect to function. Otherwise, there's some sort of knowledge leaking into the process that has no origin that doesn't explain it. So there's only two ways that that could happen. One is that time is reversed and like natural selection happens in the future and then it affects what happens now. And so the cell is like choosing its future fate based on having already been to the future. Okay. And that's a door. I'm just marking that door, but I'm not opening it because I don't think we have to. So the other door is that there's something cognitive in every cell that allows it to make decisions. And in fact, that's primary. And then natural selection's after the fact. So we have all these results now about cells, deliberately altering their DNA. So we have like all this evidence of non-random mutation. We have horizontal gene transfer, epigenetic inheritance, karyotype scrambling, which Dr. Hing calls, genome chaos. We have mobile genetic elements and all those things that are direct experimental evidence that cells have some sort of control over what their basic code is. And so the question is, where does that control come from? So, you know, I think most biologists now assume that there's something else in the cell that's heritable, right? There's some other like emergent properties of the cell are heritable or something like that. And that those are what are controlling that process. Okay. So that's like kind of similar to epistolution. It's kind of similar to cognition first, but actually it's not. Actually, what I'm arguing is actually that's not at all cognition first. So all that is creating another type of gene, right? So the gene is something that's inherited, that's shaped by evolution, that then controls traits, right? And so if it's shaped by inheritance and it controls traits, it's a gene. Like the only other definition of the gene is just a sequence of DNA, right? That codes for a protein. So whenever you introduce this sort of philosophical definition and you say traits come from X, they come from genes, right? If you're talking about something heritable. But if you're talking about something spontaneous, something that was just invented just this minute, you're talking about cognition. Okay. And so I'm arguing that it's incoherent to think about if we call it cognition and we think of it as completing the theory of evolution, then we can't see cognition as serving inheritance or serving homeostasis, right? Because that goal, like homeostasis or like becoming a Kantian whole or survival and reproduction, or any of those sort of self-oriented goals, continuance of the self, all those goals, the only place they can come from is inheritance. And so this is a big like philosophical kind of wow moment. So I'm hoping I can make it clear and you guys can challenge me on this. But if you think about like what sort of information is present to the cell, like the cell itself doesn't have any vision into, it's not a lineage. It doesn't have any vision into survival and reproduction. The cell is only aware, just like we're only aware of what we've learned from the world, like what we've taken during our lifetimes as information from the world and put it into ourselves. Like we don't know whether what we're doing is going to have reproductive consequences or not. Like that's not something we have vision into as individuals. Our lineage, that's only like natural selection only operates on the level in the domain of the lineage, not in the domain of the individual. And so that's the big aha. Like if you see it that way, then you realize cognition can't possibly be in the service of inheritance, trying to make the organism continue into the future. It has to be doing something totally different. It has to be making the organism learn something, which means changing. So like change and stasis are opposites. Like forgive me for being totally, you know, like simplistic, but they're opposites, right? So if you're trying to stay the same, homeostasis or continuance of yourself as you are, that's different from trying to change into something else, right? And so I'm arguing organisms are actually trying to change into something else. And that actually explains senescence. Like it explains why we eventually our biology becomes incompatible with our own further existence. And so, and among a lot of other things it explains, but let's start there.
I mean, so Charlie, as you often in our conversations, you often draw this distinction between, faithful reproduction or fidelity versus plasticity, right? And it's certainly an interesting idea, but it's not as though neo-Darwinism doesn't have a mechanism for plasticity. Random mutation is a mechanism for plasticity. So why are we making this leap from, okay, we've noticed some behaviors in cells that seem like it's a cognitive process, to saying that some kind of cognition must be driving somehow this plasticity process? Why do those things have to be connected?
Yeah, so it can't, because genes are not like DNA sequences are not expressed randomly, right? They're expressed systematically, like in this goal-oriented process of differentiation. And then now we're looking at like the evolutionary changes in germline cells, and we're seeing that um, even in germline cells, the protein coding sequences are protected from mutation. And the more they're expressed, the more protected they are from mutation, right? So, so the cell deciding which proteins to express is causing the heritable mutations to be greater in regions that are not expressed. So like the causal loop is reversed. And it just so right there, that's like a fundamental problem, right? Because if that indicates that the choices the cell makes determine the path of evolution, right? So that's an illegal move. And so we can't, so now we have to say where is the knowledge that's driving those choices coming from? And it can't be coming from inheritance, because the cell itself doesn't have any visibility into inheritance. It can only see what it knows about the world, right? And so that means there has to be a whole separate cognitive process embodied in every cell. Yeah.
Well, so it seems like the people in this group are onto and beginning to strongly believe that there is a cognitive process involved in the cell. But why that process has to be the driver of change and adaptation, I think is still maybe not totally clear. But so I guess maybe one way of trying to make it clearer is this question: is it that is cognition, in your view, something that emerges over the course of the evolution of a lineage, or is it the other way around? Does cognition produce the process of inheritance somehow? Right? It seems like the usual assumption is that some form of cognition arises out of an evolutionary process, but it seems like what you're saying is turning that upside down. Can you
Yeah,
tell me about
like
that?
so there can't be an evolutionary process until you have cognition, right? So until you have cognition, you just have crystals, basically. So in order to have evolution, you have to have individuals, and they have to reproduce themselves. And that requires plasticity. So that's the whole riddle of life. That's why we don't have a good physical like solution for how life occurs. And we can't just build it whenever we want. We have to take cells that are already alive and manipulate them to get anything biological. So yeah, so there's two different parts there. One is, first of all, like, this concept was already embedded in evolutionary theory when it began. So Darwin's assumption was that use and disuse shaped the variation of organisms. And like not only Darwin, but Dennis Noble says that not only Lamarck and not only, you know, everyone before Darwin, but also Darwin himself and also everyone around the time of Darwin assumed that use and disuse, the choices that organisms make, leads evolution in a certain path. So like it was already totally consonant with natural selection, happening from the beginning. And so this like it doesn't contradict that. It just like says um that's how we get plasticity, right? Is we're trying to do something that changes ourselves. And so that's totally different from seeking homeostasis. Now, So if you already are something that does that, that doesn't rule out other lineages being eliminated. And if you happen to reproduce, that explains why there's a lot of like tendency towards reproduction in all the lineages that are existing. They are the ones that happen to have a tendency towards reproduction. I mean, that's like self-evident, right? Like, but it doesn't prove just because we have that tendency and other lineages were removed, it doesn't mean that that's the thing we're searching for, that that's the thing we're doing with every decision we make. Um, so does that make sense?
Yeah, I mean, Darwin had this idea of like gemmules, right? That somehow the cells of the body would communicate with the germ cells, and that, and now we've seen, and we had a whole presentation 3 months ago in this group about how that is that we see that actually happening. For a long time, we thought that was not possible, right? But why is it cognition that drives that process? Why can't it just be some other sort of mechanistic process that maybe we don't understand yet?
Right. Um, so meeting meeting survival challenges. So wait, there was another part I wanted to mention here, and now I've lost it. Um, anyway, okay, why does it have to be cognitive? Why can't it just be um, accidental? That's the question, right? Why do these changes?
Accidental or just some sort of mechanistic process that doesn't require like a cognitive. I mean, when I think cognition, I think there's memory, there's information processing of some kind. There, right? So why can't this communication between the cells of the body and the germ cells, or whatever the process is in a single cell organism that allows inheritance to happen? Why can't that just be mechanic? Why is that cognitive necessarily?
Well, the fundamental question is, what is cognitive? What does it mean? And if you suggest that anything to do with the inheritance in the DNA is not cognitive because it's static in nature, then anything that's not static in nature in the cell is cognitive? Is that what we're talking about?
I think that's a fantastic question. And I'm not sure, well, I feel like the topic of what we're trying to get to in this discussion is sort of the elucidation of these ideas of epistolution. And I feel like that's an even more sort of bedrock question. So what's the nature of cognition? I don't know. Charlie, do you feel like you have a sense of a way of sort of concisely defining what we're talking about when we talk about cognition?
Yeah, it's totally. I mean, it's building explanations of the world, right?
Yeah.
So the idea of cognition is that a cell is a mind, and not like figuratively. It's not like metaphorical. Like it really is a mind, like there's a mind is composed of memories, and consciousness is somehow involved. We don't know how. Like we still have minds when we're unconscious. So we're not sure, but we know that there's an explanation of the world. And that's what we mean to be aware of the world, to be cognitive, is that we have some sort of understanding, which means an explanatory causal understanding. Like it's not just correlations, it's causal, right? It's some sort of causal map of what wiggles what. And so that's totally different from um, a lot of things that go under the name intelligence. But yeah, so it has to be something like that because I mean, if you think of any like what would be the other fundamental drives and where would they come from, right? Like you have to because if we're saying it's not about inheritance, it's not about protecting myself from change, then what is it? Like it has to be something that somehow incorporates knowledge about the world. And because I mean, evolution isn't producing useless stuff, right? It's producing very useful tools and all kinds of things that we call adaptations, which is everything we see, and we have all these incredibly intricate stories about how useful these things are. And they're all based on the idea that they would um, promote survival and reproduction. And so the biggest thing we have to grapple with here is why does everything masquerade as survival and reproduction? Okay. Why does everything look like it's trying to survive and reproduce? If it's not, if it's trying to be cognitive, it's trying to understand the world, why does it look so much like it's seeking out mates and seeking out food and doing these things that are obviously trying to promote inheritance? Well, the reason is that the two goals overlap quite a bit. Like if you think about what a mind needs to build up an explanation, it has to remain a coherent entity, right? I mean, that's the nature of explanation is it's a coherent entity that explains the world around it. So you can't have an explanation and then you take out a big assumption, just rip it out. It doesn't work anymore, right? It has to be it's an intellectual entity, right? But we're saying it's also a physical entity. And so it has to be coherent within itself and it has to be coherent with the world around it, right? So that's what an explanation is. And so if you think about what kind of physical structure has to hold an explanation, it has to be some sort of physical structure that can readjust to the world, but it also uses the world to rebuild itself. So when we see these experiments like Mike Levin's experiments with planaria, you can see 250th of the planarian can be removed from its body. And then without any genetic input, right, it can regrow into a two-headed planarian. That's how we know that it's not a genetic program because it's growing into a two-headed one instead of a one-headed one or a two-tailed one or however he's manipulated it, right? So the pattern rebuilds itself all the way back. So the information it's using is only the little fragment that was in the 250th piece and also the world. So the world around it contains truths, regularities, like we call those truths, like causal relationships, right? Things actually wiggle other things in the world. Like things are true and not true. And then so an explanation has truths built into it. And they're not perfect truths, and they're subject to update, right? But they're coherent. Within their domain, they're coherent. And they
Pretty much everything you have said here about the coherence and the influence of the environment and so forth would also apply, for example, to a raindrop falling through the sky, being buffeted by, a wind this side and that side. It has a sense of coherence. It pulls itself together. Now, if what you're arguing towards is panpsychism in some form, i.e., that little tiny raindrop, it doesn't know anything about the world. It knows nothing about its DNA or origins, but it knows its own self and it feels the forces of nature on it. And in my view, I'm panpsychic, that droplet is aware, it's self-aware, and you observe its behavior. And when you bump it this side, it bulges out that side. That's cognitive behavior, in my view. Now, if
Yeah.
that's what you're arguing, then I'm totally with you.
Well, thank you, Steve. That's why you're a scientific advisor for Talking Octopus, because you believe things like that. Yes, I mean, we're going to get into that harmonic resonance and why that's such a great explanation. But I do think that we have to go further than just resonance because organisms have a self. They have an inside and an outside, and everything resonates, right? Whether it's a self or not. Everything doesn't have an immune system, but every organism does have some sort of coherence. But that's the reason. The question I was answering is why does everything look like it's trying to survive and reproduce? Why is it masquerading as that? And the answer is cognition has built into it the fundamental property that it tries to make itself coherent. And so if we're out there seeking better explanations, like part of seeking better explanations is not destroying the ones we already have, right? So we're not gonna like we're as epistevolvers, we're not going to go too far in the direction of crazy experiments that like rip out half of our brain, because we're going to kind of have the sense that that's immoral because we're going to lose knowledge there. Like that's not a good direction for us to go in. And so we tend to avoid those things. And all organisms tend to avoid things that destroy their own coherence because they're trying to maintain coherent explanations of the world, not because they're trying to pass their lineage on. And so obviously they do pass things on, right? Inheritance does exist, but that's how that can happen by chance when you're trying to protect explanations, and intrinsically you become regenerative if you're that type of entity, right? Because if there's a coherent resonance to your explanation internally and you take out part of it, that's one of the properties of resonance that makes it so attractive as an explanation, is that it can rebuild missing parts pretty easily, like because a pattern of resonance, fits within itself and extends the information further spatially than it already exists. So when we have brain patients, who's have brain lesions and they lose all sorts of memories, and then the memories are somehow magically recreated, we know they're not genes. Like genes don't genes didn't give those memories to the patient, right? It's definitely not through inheritance that they learned those things. And yet their brain recreates it in a new part of the brain. Like, so this is an explanation. It's that the whole organism is a cognitive entity and is actually physically an explanation of the world. And so that leads us off into a totally new world in terms of the consequences of what we need to move biology forward, and what we need to
So
actually understand biology.
I think, we want to take Stephen's comment really seriously, because I think it's a really important comment, because there is this question between, is there some difference between what you're espousing and some version of panpsychism, right? So, maybe along with Michael Levin there, who talks about there being a sort of a spectrum in terms of cognition, or in terms of what it is to be a mind, right? There's these sort of processes that we might have traditionally thought of as kind of mechanistic, like the way a raindrop holds itself together with whatever surface tension and blah, 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 all the way up to, I don't know, cognitive human beings. So there's this spectrum, right? But you seem to make a very clear distinction at the point where you talk about life versus non-life, right? And so there's maybe a kind of cognition functioning in an organism that's a different type of cognition, perhaps from the kind that Stephen's talking about. And I guess, to get back to the sort of the earlier question, why can't we see cognition in a cell and just have it be sort of instrumental to survival, right? Why do we have to rewrite the idea that the sort of basic process of life is a process of the reproduction and inheritance? Why does it why does it have to be that there's an explanation for the world happening? It seems like that's one of these leaps that maybe people have a hard time taking along with you. I want to hear more about that.
Okay, because lineages tend to persist, right? I mean, they tend to stay around, and so they have to be getting knowledge to stay around, to stay alive. I mean, matter doesn't just stay organized, right? I mean, the whole thing is negentropic. It's like against entropy. These processes stay organized, and that's why science is focused so much on this problem of self-organization and self-protection, and seeing everything as a Kantian whole, or some sort of self-propagating physical system that exists for its own propagation. So, I mean, that problem is still part of what we have to explain, so, but yeah,
maybe put even a finer point on it. So like you look at Barbara McClintock's work, or you look at Michael Levin's work with the caterpillars that, they become butterflies, and their entire nervous system liquefies, and then it reforms in the shape of the butterfly, and yet it remembers something that it was taught in the caterpillar form. So there's some sort of, something's happening, right? There's some preservation here. But why does cognition, if you think about McClintock's work more and the sort of shuffling of genes, why can't cognition just be something that comes in just in case of emergency, right? That there's some sort, like I cut a planarian into 250 pieces, that seems like it would qualify as an emergency. And so why isn't cognition just like an emergency mechanism that comes in and helps the cell or the organism to regain some kind of structure? Why does it have to be the driving force?
I don't understand the question, because things learn, right? Organisms learn things, so like in non-emergency situations all the time, organisms can learn things, like they can associate and they can learn new things that, like, so Mike shows, that planarians can learn about barium, which is something they've never encountered in their evolutionary history presumably. They can learn to be resistant to barium, and they can like learn, and that's just, I mean, that's planarians, but everything, obviously all kinds of complex animals learn all sorts of stuff, and it's not an emergency. So, and it's not a random process. I mean, you can teach animals, like you can teach plants even. So,
Yeah, well, I think part of what you've been saying, it has to do with the distinction between something that is a self, as you started to say, and something that, is a
yeah,
raindrop, a self.
exactly. Yeah, yeah. So we got it right. So that's how it connects. So it connects to Steve's comment really carefully because um, the point is epistolution doesn't exist just everywhere. It can't possibly. Like everything resonates. Everything has like resonant frequency, like all matter is a wave and all waves can interact, in certain ways and not others, so forth. So there is resonance everywhere. And like we think resonance has a lot to do with epistolution, but epistolution is a very, very special form of resonance. And it's because there's not life everywhere, right? And everything is not alive. I mean, there are certain characteristics of life that only exist in this thin membrane, as far as we know, on the surface of the earth, basically, and down in the earth a little ways and up in the atmosphere a little ways, but basically in this tiny membrane, and all of outer space, as far as we know, is lifeless. The interior of the earth is lifeless. And, most of the things with inorganic material that we deal with is relatively lifeless. It doesn't have these properties. And the point is that these properties lead to inheritance. So if there were other epistevolvers on earth, then there would be other branches on the tree of life that didn't cooperate with DNA that would be out there. And instead, all we have is everything coming from one more or less wellspring and all sharing DNA universally. And so that's probably time to transition to that, because we've already been talking for like 30
Yeah, I was thinking so a question that gets to that next point is, if I'm thinking about a neo-Darwinian model of the way that things change, the way adaptation and evolution, I see a strong role for reproduction and inheritance there. But
Yeah.
if I'm thinking about a world full of epistevolvers, I guess I don't even understand why is there senescence, but maybe we'll get to that in a minute. But why even inheritance? Why do you need inheritance? And
Okay.
how does inheritance emerge?
This would be a good time to talk about memory. So Dina just pointed out in the chat that another really important piece of the puzzle here is that minds are composed of memories, right? So memories are not recordings. They're not precise records of whatever happened. Memories are totally different from recordings. And like all the research on memory is like memories change wildly. Like eyewitness testimony is super unreliable in court. You can lead the witness off in these crazy directions. They're kind of mixed up in dreams. Like dreams are sort of memories, but everyone knows dreams go into wild fantasy all the time. And so a mind is composed of memories. And so if we're seeing life as cognitive, cells as cognitive, we're seeing everything inside the cell as a memory. And so these memories accumulate, right? And but they're useful. And the way we use memories is like the memory of learning to ride a bicycle is in there, right? I remember how to ride a bicycle. If you pointed me towards a bicycle, I could get on it and ride it. It doesn't mean if I'm in the vicinity of a bicycle, that memory doesn't force me to ride the bicycle, right? I still have a choice of how to use my memories. And that's exactly how cells interact with their DNA. They choose which ones to use and how to use them. And they produce novel combinations. And like the people who've done the sort of math on how many ways, the 250,000 or 25,000 genes in the human genome can be independently combined is a number, way super astronomical number, right? And so, but nevertheless, every cell in your body is deciding which ones to use all the time in the right way. And so none of that's random. Does that answer is that getting into this DNA thing?
Yeah, I guess it doesn't fully explain why inheritance, but I guess we're talking about a mechanism whereby memories can be stored in a certain form, and I think you're you're implying, or even just maybe you said that DNA forms this structure. This it's a kind of like a, I don't know, it's like flash drive. And then, but there still has to be a mind that's accessing that and even making changes to it at certain times. There has to be some kind of cognitive process making those changes. Is that?
Yeah, well, all it is like it's just like the planaria. I mean, we're like that too, right? A tiny piece of us goes off and interacts with a tiny piece of another human and then regenerates into a whole human, you know? So like the memories we have, the point is that if we see life as cognition first, we see DNA as memory. And DNA is like this storage bank of memory, just like your neurons. Like the configuration of your neurons is a set of storage bank for your thoughts, right? For your explanations of the world. So on the cellular level, the DNA is the storage bank. And the DNA can regenerate, can help to regenerate, you know, if it's combined with something that evolves, it can help to regenerate a whole new version of that explanation that's going to interact with the world. And so, yeah, implicit in this. And remember, like there are probably many branches of evolvers that didn't leave offspring, that didn't regenerate in this functional way, right? And those are all the ones that went away through natural selection.
We wouldn't see them.
We wouldn't
But
see them, right?
so,
Exactly.
so, um, but you're also arguing that this cognitive process has to be universal across life. And what and I think that also relates, based on our previous conversations, I think that for you that relates to the universality of DNA in life. Maybe that would be a helpful thing to elucidate.
Yeah, so it has so right. So if there's universal DNA at the bottom as the memory bank, and that's the way that every cell, that's sort of the thing that every cell uses to generate its cognitive choices, you know, to pick from, to do its cognition, then it just stands to reason that the whole process has to be universal from every cell. Like every cell has to do this. Um, and it's kind of it's almost hard to imagine an alternative situation, like if you had different lineages that had wholly different cognitive processes. So this is not a problem from the inheritance first point of view, right? The inheritance point of view, inheritance first, everything's a result of inheritance, right? So the fact that things diverge, they're supposed to diverge and follow totally different rules. You know, they're supposed to be like, you know, no fundamental reason why um you know, because the DNA is supposed to be the cause of all the traits, right? But we're saying it's not the cause of the traits. This cognitive process is interacting with DNA to cause the traits, right? In every situation, and also to shape the future configurations of the DNA. Just through, you know, there is randomness in the mutation, just the way there's randomness in the way that physiology changes from sleep to wake, right? Like I think of sleep as this sort of random decay all over the body, or wake rather. Wake is this sort of random process of decay all over the body. But when we exercise certain muscles, they decay more, and our sleep process comes back and configures those muscles stronger, right? So it's use and disuse. That's the reason why that was part of the explanation of life from the beginning, is because biologists noticed that things that are used get reinforced and things that are disused get mutated or atrophied or whatever. And so they assumed that that was true at all levels. And now we're finding out that it is true. So there's randomness in the process, but did that answer your question? Or are we off?
Well, I think so.
The universal platform of DNA, right, is like supposed to be universal from the inheritance first point of view because it's the cause of everything, right? It's the reason why all this stuff exists. But from our point of view, it's not the cause, right? So these are cognitive entities that are creating memories out of whatever they find in the world, but they're all convergent on this one platform, this DNA platform. So they're using the same language, the same alphabet at least, to speak, okay? To speak to themselves at all levels. Like when I make choices, you know, I choose to like run a marathon, every cell in my body cooperates with that choice and adjusts to that choice. And the way they adjust is they they all interpret their own genomes differently, right? They express different proteins because of my cognitive choice as a whole system to go run a marathon. Like that makes a lot of physiological consequences for every cell in my body and all the microbiome cells and everything else. So all that is cooperative, integrated with the DNA, universal. And so that means that the process has to be universal. And so then the other part of the explanation, or the like sort of certainty I have there, is that the existence of microbiomes and holobionts. I mean, if you think about what has to happen, all the coordination that has to happen for our lineage, our specialized cells, to be completely dependent on our microbiome for cognition, for metabolism, for the immune function. And what that is a spontaneous assemblage of billions of other lineages, okay, that are completely unrelated to us in terms of inheritance. And they spontaneously combine into a coherent whole, okay? And then as I eat different foods, I change my diet. Like I go ketogenic, and then I eat just ice cream, and then I'm a person that changed my diet a lot. And so, nevertheless, the research is telling us that that same community recoalesces. And you can tell if I go back to the original diet, it'll recoalesce. Those same clades will be predominant in my gut. And you can map those, and they're as accurate as a fingerprint to identify an individual. So if that wasn't a coherent assemblage of evolving the same type of thing, operating on the same platform, then it wouldn't recoalesce like that. It would just diverge into like some random direction and never become coherent again. And so that's another like direct experiment. It's a natural experiment, but it's overwhelmingly obvious that every cell, at least in that system, you know, is cooperative. And so, from an inheritance first point of view, those are all just traits, and those are just the interaction of, the downstream interaction of genetic traits, right? But we've had to discard that explanation, so that we've got to change our whole mindset about what's in there and what's happening. And so it requires this universal mechanism, and that requires us to actually figure out what physical mechanism is common to all cells on Earth. And it's got to be relatively simple, and it's got to be, because it's universal, and it's got to be something that produces memories, and something that creates coherence, and something that integrates information from the environment into your physical self as a cell and at the level of the individual. So that makes it a really well constrained engineering problem. And so now, like Talking Octopus, the whole point of starting this Talking Octopus 5 years ago was to actually do experiments. And so now we've got like quite a few people that understand the concept. And now we're actually, we just launched a Patreon page. We're trying to actually raise money and actually do these experiments. This is like I've been trying for a long time by myself, but now there's enough of a community that, if we take this idea seriously, then we have to follow the consequences and try and figure out what the universal mechanism is. And we have to tell other people so they can try also. Yeah.
I feel like we could continue for a long time, but I just want to do one last thing, which is, it seems like in your paper, you listed a number of assumptions, or you at least tried to explicate a number of assumptions that you feel like people who accept a sort of cognition first, or a level of agency operating at a cellular level, people who accept that notion should, according to you, also go down this path that leads ineluctably to epistolution. But they're prevented from doing so by a set of assumptions that seem to have a very strong grip on the sort of scientific thinking of a lot of people, even who are radical enough to accept the idea that there's, right? And I don't know, do you want to talk about what some of those assumptions are, and how you see them as tricking people out of being able to see that epistolution is the inevitable.
Totally. Yeah, totally. So the list of these assumptions, and these are like just completely exploded by this, but the problem is they're so deep, they're really hard to like remember where they apply and where they don't apply. So we end up thinking this way without realizing we're thinking this way. So here's some of the assumptions. Cognition is evolved, so it has no underlying universal rules. Cognition is unlikely to be possible outside of carbon-based life. Cognition is a selfish tool for survival and homeostasis. Cognition has to come about through billions of years of evolution. Cognition is not connected to morality or the development of our values. Cognition is not looking for correlations in cognition is looking for correlations in data, and cognitive systems can be given goals by their designers, and cognitive systems can be unaligned with humanity or human values. So all those assumptions come from an inheritance first view, and all of them have to be thrown away when we look at it from cognitive first point of view. And so like Talking Octopus is all about like throwing all those away and assuming cognition first is right. And then, that's what the world looks like. All those assumptions are false. And um, so that's the
I mean, it seems like embedded in your paper is a strong accusation, which is that even people who believe in cognition first are still sort of out of habit thinking inheritance first.
totally. Yeah.
And those assumptions are the things that flow from an inheritance first view. Well, I don't know. I have another set of questions, but maybe let's just move on to the punchline, which is how if you're able to find this mechanism that you say is universal, exists in all cells, all organisms, must be relatively simple. DNA functions as a sort of a memory system for the product of this cognitive system, and all of those things. How does that solve artificial general intelligence for us, among the other things that you say it could solve?
Yeah, it solves everything. I mean, because in principle, because we are a result of that. So everything we do, these things can do also, but do better, right? Because the idea is once we know the mechanism, we can build them. And once we can build them, we know the mechanism, we can build them to whatever level of complexity we want. And they'll have the same characteristics of human newborn children. They won't know anything at first. It'll take a long time for them to learn anything. It's not like an AI model where it just snaps out of the box and it's brilliant, and you just launch it into the world. This is like, we're talking about something that has to learn from physical reality. Well, once a bunch of them have learned, it's possible we can clone them, but they're still going to have to be like children. I mean, we're going to have to we're going to have to teach them and talk to them. They'll have their own ideas, but we know that the ideas will be consonant with our moral values because and they'll go on to improve our own moral values, like in the way that our children improve our moral values. Like, I don't assume that Eva is going to grow up with the same prejudices that I have. I think that she's going to, because she's growing up in a like kinder, more humane world where people have better values, she's going to adopt, some improvements over the things I believed when I was her age. And it's going to go like that. And epistemologists are just like that. Because I mean, literally our values and our goals, these all come from the same cellular process that constitutes us. I mean, it's our, it's the fundamental drive of all life. And if it's knowledge, then that all makes sense now because knowledge is shareable, right? Like it makes sense that this is the basis of like love, like the things we love, the things we cherish, the things we think are valuable, little babies and puppies and, hearts and rainbows. Like these things are beautiful to us because of the knowledge that's embodied there. And so, knowledge,
I mean, it seems like if
like selfishness, like homeostasis, you can't share with other people. Like that's like world of red and tooth and claw, right? Like there's nothing about my homeostasis that necessarily benefits you, but if it's my knowledge it obviously benefits you, right? And the closer you are to someone who's knowledgeable, like we can always get more by being in tune with other people and by communicating and by developing each other's knowledge. That's like
Okay.
totally shareable thing. And so then that makes sense of why life would be so cooperative and many other things like camouflage and senescence.
Well, well,
And
before we talk about, I mean, well, we want to let other people ask questions, but I just, um,
totally.
can you say just a little something about how the worldview of a planarian or a bacteria, I mean, it seems like we're not going to be talking to if we're managed to somehow recreate or artificially create this cognition that exists at this very simple level, how does that relate to like a higher level kind of general cognition or general intelligence?
Yeah, so that's a mystery, right? It's a mystery why um, some things can communicate with each other and other things can't, right? So why is a holobiont able to form? Like I can't form a symbiosis with a compost pile, but I can with like these gut bacteria in this certain combination. And that's a mystery. Like we don't really know how it scales, how the self scales. And some things can become the self and some things can't, right? I mean, there's an immune system. So like some bacteria can get into my body and my body fights with everything I've got to expel those things, to kill those things. But other things, can be part of my body, no big deal. And so we don't know. But we know that knowledge is being shared between everything that's within the self, and it's kind of a democratic process. Like if you have a stomach ache, it throws off you know, your SAT scores.
But you seem to indicate that it would be some usefulness to even this kind of cognition that might exist at a single cell organism level. Even,
Well,
even
presumably we've got to figure out that what are the principles that allow it to scale? Like,
yeah.
what is it about an organism that's not a compost pile? You know what I
Uh-huh.
mean? Like, why are we not a compost pile? Like, there are many, many organisms in a compost pile, many cells, but as far as we know, the compost doesn't think and it doesn't have an immune system and it doesn't defend itself and it doesn't regenerate itself. So it doesn't have the properties of life that make us think that it's a coherent epistevolver in and of itself. And so, like we know individual cells are epistevolvers, but
Well, my compost pile seems to
cellularity
be able to
requires.
create skunks, raccoons, and various other kinds of animals just spontaneously. So maybe there's something there. Um,
Totally.
uh, I don't know. Dina, is there anything we missed? Is there anything you want to chime in with before we open it up?
Yeah, the thing that, yes, but you can skip it if you want. So, Josh, uh, you said connect this to AGI, and Charlie, you started talking about raising talking octopuses. And what I wanted to flag was that there's great value in even in identifying and being able to locate and eventually manipulate just this mechanism of cognition that comes way before the final conclusion. And that's what I was hoping you guys would talk about a little bit is, um, you know, how does this relate to AGI? And I think that Charlie and Josh, we've been talking a lot about what could you actually do with this in the real sense, even before you got all the way to the end of creating an actual organism, like an artificial organism. That's the thing I was hoping you'd go to, but I think that you could also skip it if you anything to bring in the other people's thoughts and questions.
Yeah, I mean, I think it's a pretty short distance, I mean, because if we know what it is, like we already have the tools to scale things up really fast. Like if we know the algorithm for the intelligence that's residing in one cell, all we have to do is build a computer program that scales that, and it scales the compute that you require, but it, it immediately can be superhuman. But it's AGI, true AGI. So true AGI depends on understanding the world. It doesn't depend on how complex it is. Like whatever true AGI is, it's in every single cell, no matter how simple the cell is. Yeah. So
I think it'd be amazing to hear from the group.
yeah, I want to hear like all the hard questions. Thank you guys. Thank you, Josh.
Yeah.
Well, could I say something?
Absolutely. Absolutely.
Okay. So why do you want to actually use a cognition against the inheritance? Because from our point of view, I just tell one story, right? We learn from the cancer. So if you try to kill cancer cell, but if you use a very gentle way and gradually you kill them without notice, everything's fine. But if you want to use the nuclear bomb, right, suddenly powerful every force to kill them,
Right.
then the cancer lose themselves. They actually become something else. So why the so-called self actually, you're looking back for the evolution right now. Every time, no matter how successful the species is, they will be replaced. So traditionally, we think lots of Darwinian evolution, some basis you're thinking, rational, make you get the conclusion is not there. So should we actually looking back, to thinking about what's the evolution is, and what's the pattern of evolution, and then we thinking where is the cognition to play the role, right? So that's what we try to thinking about. So in the past many years, we actually use very simple way to thinking if the cognition is a form of the information, right? So we're talking about information management. Therefore, we realize that the inheritance is very simple stuff, but it cannot be replaced. Why? Is because the inheritance is preserve the information, nothing else. So don't get this very. So when you have self-organization, you have a miracle, and by equivalent, they are going to disappear, as you're talking about, right? Evolution actually is just for the consistency, it's not for the change. So we actually betraying we think evolution is change, but evolution is conservation, right? For most of the time, it's complete conservation. So therefore, we should not perhaps consider because inheritance is the platform, is not the identity. And cognition is identity during the process. So we actually cannot use the cognition to replace the inheritance, but it's totally different platform and the system involved as such.
Well, yeah. Well, I'm not trying to replace inheritance. I'm trying to explain inheritance.
Now,
Right.
but if you
I'm trying to give inheritance some reason for happening, so like the individual cell, like when it undergoes like this intense bout of chemo, it can't be thinking, it doesn't make any logical sense for it to be its cognitive process to be thinking, I need to survive and reproduce so I can pass on my genes. That's not in its domain, right? What's in its domain is like figuring out what's actually happening. Like the tail of my airplane just blew off, and now the seat I was sitting in is tumbling through the sky. Like what's happening? Like I'm in a traumatic situation, and it's trying to rebuild its explanation of the world, right? That's why it's scrambling its DNA, just like we'd scramble. Our brains would be totally different after a huge trauma, if our airplane blew up halfway.
No, I understand what you're talking about, but the second question that I want to say is, you put too much human-centric thinking to try to explain what the bacteria is thinking, because during the scale of the evolution, each of the stage use a totally different law to drive the information. So therefore, in that sense, we are actually thinking the new future of the evolution. It is cognition driving. First,
but it can't be changing its heritable material based on inheritance, right? I mean,
they could.
changing its heritable material has to be based on some reason other than an inherited reason. Like it has to be coming up with a new reason to put these genes here and these other genes there.
I understand. I noticed a lot of your argument is totally logic, very strong logic argument, but it's not fit the reality. So that's I feel it. So I'm sorry, I'm very directly talking about.
That's
So,
awesome.
so from the logically thinking, everything's beautiful, but it's just not true.
Okay. Awesome.
So that's something I have very strong feeling about because many of your stuff beautifully chain of the argument I can easily take the break away because it's not true. From biology, we actually studied biology. We studied the system. We studied how the inheritance emerging, how to this one. So almost like I had a feeling I'm reading the philosophical paper rather than the biological hypothesis.
Yeah. Well, it has to work both ways. I mean, I totally agree with you. It has to fit empirical results as well.
Yeah.
So Kate, I think Kate was next.
Sure.
Thanks. Thank you, Dr. Hank.
Charlie, I love what you're doing. I'm a little skeptical about ever being able to build general the kind of life that we have in cells, but I think that there are some really brilliant minds working on it, yours included. But I think what I would suggest in what I haven't heard enough of in this conversation, well, we start with inheritance versus cognition view, right? But they're in between sort of what we're talking about is the whole realm of computation, which is, of course, your goal, right? To build something that has this kind of epistemological capacity, right? And that's great. But the idea of computation is directly connected to the idea of cognition, and it's also connected to the mechanism. And so the discussions of how to get from computation to thermodynamics, those two things you mentioned entropy and all of that. But if those two things are sort of built into your story a little bit more, I think you're going to find your way to resonance in that direction, because I completely agree with you. And that's one of the reasons I really enjoy this community, is that resonance is at the bottom, because resonance is a capacity to experience something. It's a capacity to know something within yourself and to recognize something similar in others. And at the very, very bottom of the dance of parts and wholes and identity boundaries and all of that, you have resonance, I think. Like I, for an individual, feel my fundamental, and that's where I know how to go to and move from to manage my own energy flows and interact with the environment and all of that in optimal ways. And all the way down at the bottom, if you think of it from a complex systems view and the whole network dynamics, that's something that I think can really be helpful here too, because you have attractor dynamics where you get this dance of parts and wholes, but they don't know how the connection it works. And you chase this all the way down, you're going to end up at quantum entanglement and all that sort of stuff. But resonance is the secret, I think. So if you can kind of build out from the mechanisms of the embodiment, and one of the first ways I think of doing that is to really make a clear distinction between cognition and embodied senses like emotion, because there are two streams of information. One of them is very, very deep, and what you're looking for in the codes of cellular intelligence, in the self-regulatory and immune processes of the body. And there's a binary code going on there that connects to resonance at the bottom. It connects to our value systems at the top. So if you can build a computational story, which is what Mike Levin is doing. And have you heard of Blaise, what is it, Aguera y Casa? You guys heard of him? Oh, he's wonderful.
Agüera y Arcas.
Thank you. How do you pronounce it?
Blaise Agüera y Arcas.
Aguera y Arcas. Thank you. Yeah, we met him at WISE, right? Well, I'm reading his little book called What is Life right now. And he does a really, really good job of, because he's doing what you're doing too. He's, the Google guy who's working on the intelligence models. And he's got a clearer picture of the computational paradigm than I've seen anyone else put together so far. And he makes a link through entropy, which is essential to get at the mechanism and all of that. So there's more to say, but that's a good start. So one thing though that Blaise says in terms of the whole idea of thinking about inheritance first versus cognition is the whole concept of self-replication or of a replicator. And where he's really got his something by the tail is how coding sequences can develop these self-replicating patterns. And that is the first kind of replication and ultimately is going to build toward inheritance. So he's looking at von Neumann and Turing machines and all of that. So he's, yeah, I highly recommend if you don't know about his work, read that little, it's just a really cute little book, fits in your pocket, but he pulls all these major things together. He doesn't have the emotional piece yet, but anyway, that's what I wanted to say. So there might be a few questions in there.
Well, if Kate Kaufman and Richard Watson have both read it, then I'm gonna have to read it.
No, I haven't read it, but I know how to say his name.
That's awesome. Yeah, that's totally cool. Yeah, that sounds really interesting. Yeah, computation is like a whole conversation in and of itself, I think. Totally related, but it's yeah, that's a whole nother can of worms probably. But
May I?
yeah, by all means.
Charlie, I'm totally with you. Joshua, you are asking excellent questions. Thank you very much.
Thank you.
I wanted to speak to a couple of your questions and see if I can contribute something that might be useful from the point of view that I'm coming from. So I'm going to do three of them. What is the mechanism of cognition that could possibly arise without natural selection? If it's going to be cognition first, then it isn't itself a product of natural selection. Cognition has to arise without natural selection if it's truly a cognition first. What's the mechanism of that? The mechanism of that is learning. Learning doesn't require neurons and brains. Learning just requires networks of viscoelastic connections, and that's throughout biology and the right kind of physics. It means that the process is more like a prime mover towards one system falling into a state which mirrors the state of another system. That's the primary thing. That's where it begins. System A comes to mirror the structure of system B, right? And that doesn't require natural selection for that to happen. It's just what happens when two systems are in contact with each other with the right amount of elasticity and plasticity. It's related to Friston's free energy principle stuff, right?
System B being the Umwelt.
Yeah. So system B can be the environment of an organism. So system A can be an organism, system B can be its environment. But it doesn't have to be as straightforward as that, because the environment of organisms that is salient often involves other organisms like itself. So system B I often go back and forth between thinking about it as organism and environment and just two organisms. Organism A and organism B learning about each other.
Yeah. Yeah.
But sometimes, A and B are of the same kind, and sometimes there are different kinds, but they're still mirroring each other.
Totally.
So that's what I had to say about what's the mechanism of cognition. The second, you asked some very good questions about, but why inheritance and why reproduction and why survival, right? Why is it that life does all of those things if cognition is the thing that comes first? If a system can cognize already, why bother reproducing it? If you didn't need natural selection to get cognition, why bother doing natural selection? Why bother doing reproduction and survival? So Charlie mentioned that, of course, it makes sense that you need a system to be coherent through time In some sense, survival seems to be intrinsic to being able to talk about a system in the first place. But I want to talk more specifically about the reproduction part. So I think the way to approach that is to say that one of the cool things that some kinds of cognitive organisms can do is that they can deliberate. Deliberate means that you can hold one possible truth and another possible truth at the same time. And you haven't really committed to which of these things is really the truth, right? You're holding two truths which are related to each other but are not quite the same. That's a very important aspect of cognition. And that is a state which a dynamical system is driven into. I'm speaking like I know this to be true, but I don't know it to be true. I'm full of shit, but I'm just telling a story, right? That is a state which a dynamical system will get into if the environment that it's in is also that, right? If the environment is also holding a truth and, two truths, two things which are sort of like one another, but not the same, right? If the environment is doing that, then in order for me to model the environment, I need to hold two truths inside me, right? But why would the environment be doing that? Because the environment is full of things which are cognizing about their environment, right? And if I'm an observer of them, then I need to see, or I am induced to see them not just as one thing, but as a system which has a symmetry, a system which has, oh, look, what can you see? I can see A and I can see B, and I can see that A is like B, B is like A, but they're not quite the same. I can see their similarity and I can see their asymmetry as well. So that kind of holding two truths, which are different versions of a truth, but they're not exactly the same as each other, that's the cognitive analog of reproduction. It's splitting one idea into two so that you can hold two truths simultaneously, which are not quite the same. When biology does reproduction, that's what the lineage is doing. The lineage is cognizing about something, it's holding two truths, it's deliberating, right? So natural selection, when it involves reproduction, inheritance, and the rest of it that we're familiar with in natural selection, that's a lineage that's a system which is able to cognize in this way that holds multiple truths. Now, when you make 10 to the 9 of them, that's a little bit unnecessary, right? That's more like an intrusive thought where you just keep thinking the same thing over and over again for no reason, right? But the thing that's really interesting about that reproductive process is not that you made a copy of yourself. The thing that's really interesting about that process is that you are able to hold the subtle truth that these two things are similar but not the same. Right? The thing that's interesting about populations is not that you're making lots of cookie cutter copies of things all the same. The thing that's interesting about it is that they're all a little bit different. They're all slightly different interpretations of the truth. Each organism is a slightly different interpretation of the world. Okay? So that's why I think cognition ends up doing reproduction and inheritance in biology. Right? That's how that came about. And that's how you can tell a story where it's that way around instead of, well, you had to survive, and having a good model of the world is something which is useful to survive and reproduce. So that's why you did it, right? That's the usual way around. The last thing that I want to talk about is how can cognition be the drive? Why couldn't you said, why couldn't you just have cognition be the thing that you use in emergencies? The cognition that in the special circumstances where you need to do cognition, fine, do cognition. But the rest of the time, why not just do, inheritance that copies things like the same, and you don't need any plasticity or cleverness, right? And I think, yeah, you totally can do that. And some aspects of biology do that. And I don't have anything against that. But that's just not the interesting part of evolution, right? The interesting part of evolution is not copying things like the same. The interesting part of evolution is the change. The interesting part of evolution is the adaptive transformation through time. So when evolution includes or involves adaptive transformation through time, it can't be just crystal-like cookie cutter copying, right? So you can do that. That could be the default. But if that was the default, you're not doing adaptive evolution.
Mm-hmm.
The thing that's interesting is the change. Now, the change in the conventional story is just random shit happens, and if it works, you keep it, right? But the change in a cognition first story is no, you are being invited into inducing a better model of the world. That's where the change comes from. So that's how I see the switch to say, but I could do evolution without doing cognition. It's like, yeah, you could, but you wouldn't be doing the adaptive transformation part. You wouldn't be doing the part that was actually interesting about evolution and the part that Darwin wanted to explain.
Well, and I think it would, in principle, probably be impossible because it seems to require plasticity. Otherwise, there'd be like self-replicating crystals all over the place that are,
Well,
following
there are replicating
natural
crystals all
selection,
over the world.
but they're not being
They're just not that interesting, right? They don't know much.
Yeah.
They keep saying the same thing.
Yeah. I mean, but they don't, well, yeah, natural selection, they don't really go very far through natural selection, like someone.
No. Well, they're doing natural selection pretty well, I reckon, right? A crystal that copies itself identically and carries on doing so is doing natural selection perfectly. It's not doing adaptive transformation.
Yeah.
But natural selection doesn't explain adaptive transformation. It only explains holding on to things that you got by accident.
Right. Yeah. Perfect. Well said.
That was super useful. Thank you so much.
Totally. Well, Richard, about your second point, do you at this moment, well, I have two questions for you. One is the question that I just emailed you, but let me ask you this second question. The first one is, do you have any like vision as to what sort of symmetries are necessary for multiple cognizers, as you call them, to become one cognizer? Because there's this like the weirdest thing for me, the biggest open question in this whole thing is like, what is the scaling rule? Like, what is it that makes me able to scale with other people into a cognizing unit? And even like we could throw a couple dogs in there and they would help, but like, there's certain things that I can't really communicate with and become a self, and I shouldn't say I couldn't. Henry's gonna kill me for I keep using I keep using the like human point of view, but there's some cells that cooperate with each other to become cognitive selves and others that don't. I mean, there's such a thing as cancer, right? Cancer is not cooperating with the cognitive self, even though it's human cells. And so the human self is fighting against it with the immune system. And so there's got to be something about intrinsic
one of the human
resonance.
selves is fighting against it. The other self, the cancerous self, they're not fighting amongst themselves, right?
Yeah, right, exactly.
They're just doing it. They're doing their own. They're doing a different thing from what I had in mind for where my life was going. But
yeah, well,
I've only got a glib answer for that. It's like which is harmonics.
Okay.
The way that parts make wholes is harmonic resonance.
Harmonics, yeah.
But that's all I got so far.
Yeah, because there's certain parts that fit into holes and other parts that don't fit.
Yeah.
Yeah.
Okay. So
Okay.
you can't take any old parts and stick them together and make a hole. They have that resonance between the parts and the holes to do it.
That's a great answer, actually.
Thank you so much for this conversation. I've only got another couple of minutes and I'm going to need to go. Sorry. I'm glad that I got to be here for part of it, though.
Yeah, me too. That was great. Yeah. Awesome. Thanks, Richard. Mary. Mary, you're still muted. We got mute still.
Thanks for an interesting conversation. So it seems that there are holonic levels and that they're of consciousness, and that there seems to be sort of what I would call natural law of biology of organisms being drawn to come together and create the next level of consciousness, being able to think and work and act together. And there appears to be patterns that govern this. We see this in Mike Levin and others' work in bioelectricity, and also work that's been done in the last few years by Sherlag et al. On the electromagnetic pattern that appears to leave organisms when they die. And they actually used electromagnetic fields to push that pattern back into the organisms. This relates to, and these patterns appear to come in and out of realms that we would think of as consciousness. So they can be seen in slides in visually, but then they fade into not being able to see. And so this brings the idea of idealism, which is something that Levin is working with a great deal, and he's working with a number of different philosophers looking at that. And there seems to be at every level of life, from the cellular, at least the simplest cells, there is not only learning, but there's transmission. Within parts of the cell and between cells. And so it seems to me that culture, a cultural imperative towards creating the next level of conscious holons is part of what I would call the set of natural laws that appear to be emerging. And it appears that the work that we have ahead of us, in front of us at this time, is to, in every way we can, extrapolate from and observe the patterns of engineering and reverse engineering from cell to larger multicellular organism and multi-organismic consciousness, and then back down to interpret what the rules are for this collaboration and cooperation. So those are my thoughts. And it also appears that resonance is a degradation of electromagnetic signals. And it's something that is easier to handle because it's not as intense as electromagnetism, because all of electromagnetic force has a momentum that is felt in matter. So even light has a momentum. So it appears that, if there's an electromagnetic that is stored somewhat in the environment, but it's also stored in some other plane. That's the idealist point of view. And that we should be looking for, and what I spend my time doing is looking for what are the patterns of organization and relationship that lead to cooperation and then furthering of individual evolution at every level of the holons. Sorry if that was very abstract.
No, that's okay. That was great. So, one thing you said is really interesting. So I'm hoping that this search for epistolution, like, as I said, it's a well-defined engineering problem, but it's also like a math problem. So I'm hoping the thing that's hard about the engineering problem, like we can look at cells and like reason about what is in every cell. There's some material in every cell that creates a resonance. And we can kind of guess by what materials are present how we could recreate that somehow and like what it is. But the problem with doing those experiments is energy flow, right? So there's obviously, it's laid over this metabolism, and obviously the metabolism has evolved a long, long way, and it introduces all these technical problems of like maintaining the energy in the resonator. And so like Richard and Steve have, we've together helped like try to devise these experimental apparatus that sort of resonate themselves, right? That they form a loop between the resonator and the microphone, so to speak. And so there's some sort of self-perpetuating loop of resonance that takes away the metabolism problem. But the other way to take away the metabolism problem is just to solve it on the desktop through math and like figure out, so what I'm hoping, what I was referring to, the question I had for Richard before he left is like, Richard has this model of like springs and masses, as a resonator, and it's like a Hopfield network of like viscoelastic connections. And he seems really confident that that's like kind of the answer. He calls it natural induction. so my question is like, can we just build a mathematical model of those springs and elastic connections and just run it in an artificial environment and do epistolution? It's like, if we can, the problem's already solved. Like, it's not, it actually in principle might already be solved. You know, like it might just be a question of building a computer program that runs a simulation of what he's describing. And I doubt that it's that simple, but who knows? You know, it might be a lot easier to solve it that way than to build actual physical resonators.
All my research is demonstrating that the pattern is held electromagnetically, and resonance is a degradation of that pattern into a form that is useful for communicating with the molecular level of things, and for facilitating, I have to say nonverbal, because now it appears that there's actually verbal components of language all the way down to single-celled fungi. So I believe that it's electromagnetic, and it's degraded, and so I think that you have to start with the electromagnetic pattern.
Totally. Yeah. I mean, electromagnetism is resonance, right? So makes sense. Yeah. Hey, Bill, how's it going?
Good.
You just tuned in. You just appeared all of a sudden.
No, I've been here. I thank you for calling on me and greeting me. I must say I've really enjoyed this entire presentation. I think it's really valuable. I am a little perplexed since we're talking about cognition first, and there are a lot of questions on how do we justify that system and how would it operate. And frankly, I feel as though I've presented a comprehensive point of view on how this all operates through cognition-based evolution, which is enumerated in detail, justified, defended, peer-reviewed, heavily cited, and yet nobody seems to know about it. Nobody seems to care. All of the questions that have been asked are excellent, highly pertinent. And once you understand that it has to be cognition first, there are completely coherent answers. It has to be cognition first because that's the way it is. I know that sounds a little absurd, but it's not. We actually date the origin of life by certain properties of cells that they are capable of living in the colonial form. We date the origin of life through stromatoliths, and those are that's fossil remnants of biofilms, ancient biofilms, 3.7 billion or more years ago. That's how we do the origin of life. We extend it a little bit backward with DNA work, but we know that cells from the first moment we have evidence of them exhibited certain collective properties, which are intelligent behaviors. So cognition first is the system that we have with, and it's embodied in the cellular form, and we are cellular beings. So it's not circular logic. It's like saying, well, what would we do if we had 3 suns? Well, I don't know. We only have one. And we have a life system that is based on cells, which is a cognitive endowment that was instantiated in cells for reasons that I certainly don't understand and no one else does. But knowing that, we can build a very coherent biological system. And from that, we can derive the proper avenues for research going forward. The question was, why isn't it just cognition sometimes? Well, it's not cognition sometimes because cognition is the propulsive agency and life is problem solving. And cognition is problem solving in action. The problem that most people face, and Charlie, you presented a very good point of view, we're encumbered by old ideas. And one of the major old ideas that has to be reformed is the concept that natural selection is a force, that it works, that it's actually a good idea. Well, the concept of a selective mechanism in biology is certainly a terrific idea. And that wasn't Darwin's actual thinking. Many others had come up with that before. He was the best proponent of it. The selection that actually exists when you start with a cognitive system is cognitive selection. It's the most simple proposition, and it's ineluctable. There's just nothing to be done about it. Once you put cognition first, then the system is cognition driven. That means it's a collective, it's a process of cognitive selection in which cells choose their tools. And very importantly, genes are their tools. And genes are their tools of memory. So Charlie, your point about memory is imperative. I'm so happy you brought it up. What does DNA actually preserve? It's solutions to problems that cells have encountered and solved because they exist, they continue to exist. So, and why is it DNA? Well, the answer to that is it's the best thing that cells know in which to encode their memories, but it's by no means the only thing. There are RNAs, there are biomembranes, there are tools of the cell that are everywhere. We just focus on DNA all the time because that's what we learned to think about, and we're still used to it. And so the real thing that we need to do through an organization like Talking Octopus is break free of these old shibboleths and embrace an entirely new framework with cognition first. This is entirely and completely detailed in cognition-based evolution, which I invite you all to look through. And if you don't want to buy the books, I'll send them to you. Just send me your email and I'll mail you a copy, and you can judge for yourself whether the questions get answered. And you may find that the answers don't suit you, but they're entirely there. And Charlie, I think you do a terrific job in bringing this group together. I think the questions that get raised are imperative. And I hope that people have an open mind about finding solutions. I want to add one last thing, and then I'll be quiet. Your point about reproduction is very important to me. This, again, one of the old ideas is it's all about survival and reproduction. Well, it's certainly survival because things have to continue. But the point that's been missing in biology, which is extremely important, is it's all about preference. Cells have preferences. They have homeoretic, dynamic states of preference, which they will exert themselves. They'll do work. They'll use their cognitive endowment to do work, to sustain themselves, and importantly, in preferential states. And in order to do that, they have to use uncertain information so that they are in continued confrontation with the environment. And the reason that cells reproduce is exactly what Richard was pointing out, because that's the only way to get variety. If there was immortality and there wasn't reproduction and replenishment, then you would have stasis, which is the actual enemy of homeoretic dynamic balance. It's a kinetic system. And so if you read what I've written, I invite you to do it and you'll understand the system. And I think you'll find it illuminating. But of all the things I've said, the most important one is that it is cognitive selection, not natural selection. That is the propulsive agency in biology. Cognition-driven selection.
Totally.
Can I just break in? I'm sorry. I know Catherine has her hand up. I just, you know, it's so interesting and impressive when, you know, Bill, you have this view that very much supports what Charlie's saying, and then Richard also had a view that really supports a lot of Charlie's ideas. And then, you know, I just want to point out that we also have in the room, like from Henry's perspective, you know, Henry's saying like, this is a great idea and this is a great philosophical model. It just doesn't align with what we actually see in reality. And I'm just, I think that tension, I think out of that tension is going to grow the most fruitful learning for us in this. And I'm curious to hear more from Henry. I don't know, Henry, I wanted to say this before maybe you took off from the meeting. I didn't mean to jump ahead of Catherine fully. Henry, please stick around because I want to ask you that before we're done, if that's okay. I want to ask you something specific.
Sure.
Thank you.
Yeah, well, I have a follow-up question for Bill, just because I've heard you say this before, Bill, and I loved your book, and I've learned a ton from your book, and I think it does a really good job of describing life from a cognition first point of view, but it doesn't give me the solution. Like, it doesn't answer all the question. The important question is, how does it work? Right? Like, build me an artificial one, build me an artificial epistevolver, build me something that
No.
understands its environment without using a cell membrane and
Yeah.
a cytoplasm and a packet of DNA. Build me one. And if you can't do that, then it's not a cognition first point of view, because if the only way to build that is through evolution, then it's an inheritance first point of view. Like,
Sure.
that's how that tracks, at least for me. And I wonder if you see it differently.
Well, with the utmost respect, because I think you're fantastic and do a fantastic job. No, I don't agree with that at all. I can't build it. I'll tell you why. And we're not going to build it. But in fact, I don't know that we'll ever build a conscious AI, because the super sauce of cognition, of cellular cognition, is actually consciousness. We can skip the word cognition and go to consciousness, if you will. But I think cognition sits better with most scientists because it directly goes to the properties of info computation, which are actually essential for the living frame. But most importantly, there's a duality to consciousness that goes beyond simple info computation in the sense of raw values. It includes valence, which is why the word preference has come into my conversation, and why I think there's a fundamental misunderstanding of biology. Cells are reacting to sustain themselves for preference, which is experiential. Because cells have to measure their information because it's uncertain. There's, from the point source of any environmental stimulus, there's inescapable variance from the source. There's degradation by travel time, by intervening media. So cells must measure information. But why? Because their information is imperfect.
But
By
why
the
can't
measurement of imperfect information.
like, why can't we build something like that without using
Because we
this?
have no concept whatever of how to build valence. We can build computation, but we have the slightest understanding, not even the first kernel of understanding of how to make that step. And so AI, as we are generating it, will not have that property.
But if we know all cells are doing it, then that gives us a lot to work with, right? I mean,
It certainly does. But I want to say that we don't have to understand exactly how that facility occurred to use it for our betterment. It would be like saying I have to understand why the sun exists in order to build a solar panel. The two are not connected necessarily. I believe that the important point of cognition-based evolution is it establishes a coherent set of pathways that offer explanations for the organisms that we have and why they're sustained over time. What we can learn from that is how to concentrate on those specific properties of cells and how we can leverage them for our benefit, which is how cells choose their tools, why, when, which ones, and how they choose their partners in order to develop the living synergies that enable life on our planet. That's what we can see as our observational truth. These are the life forms that exist. We can explain how they're here by understanding the actual ability of cells to make their selective choices individually and in partnership through their combined ability of info computation and valence. The fact that I can't understand how to recreate valence doesn't stop me from profiting by knowing that the system exists the way it is, and to learn how they get leveraged among living entities. And so, yes, I think the single greatest mystery that exists in science today is the origin of cognition, of consciousness. I am not the person to answer that question. I won't pretend that I know. But I can answer how a coherent, robust system evolved from that moment forward, from that instantiation forward.
Cool. Thank you. Catherine's had her hand up for a minute.
Oh, wow. Bill, I just want to say I have not read your book, but I'm on board with everything you're saying. And are you the one that wrote about the sea gnome?
Yes, I'm the co-originator of that with Francis
I
Epistolution.
love it. I love it. I'm an emotion researcher. I completely agree with you. I have been looking into valence for quite some time, and there's some really lovely stuff going on there. One thing I just want to say quickly to Charlie is I'm completely with you on a revamp of evolutionary theory, and that's going to be probably the best way to convince more scientists to think differently about some of these assumptions. And Stu and I work with developmental Scott Gilbert, right? He's a really big name in developmental biology, and they are he's advocating an Evo-Devo extension, which I think is wonderful. But what you're getting toward is what I advocate, which is an Eco-Devo extension, because the behavior of animals, the behavior of systems, which is ethology, has been part of the story forever for the very reason that there is sentience first. We had to figure out how to read our environment, what was good for me, what was bad for me, from the very beginning. So that needs to go in there. But the fact that it's driven by emotion, and Bill said it too, valence is where we know value. Valence is how we know when we are in a good state. It's because resonance is perceiving something. That's consciousness, that's sentience. And if you can follow that strand down to the resonance, and I noticed Robert, my friend Robert, has his hand up. He has some very clear ideas about what's called a phase lock loop, which is how this collectivity happens. And there's a whole bunch of stuff from nonlinear dynamics like Scott Kelso, and how there's this binary language and coordination going on. But Robert is the one that I've been the most astounded by, because he noticed that what I was saying is what was just happening in this little cybernetic control loop that's emotion, is that there's a comparison, which is the same thing they're using in active inference models. And then there's the surprise or error signal. And then there's a self-correction. And I'm advocating that the hedonic valence is both the signal and the coupled behavior with it. And I call it the fundamental semantic information bit. And I think that's what you're getting at. But that, looking at Mike Levin's work, that what's going up and down is membrane voltage. And this is the connection to Robert's. I noticed you had your hand up a minute ago. If you can explain the phase locked loop, that's a very important step here to the mechanism, both that cells are using to know their right state, get to their right state, and harmonize with others in a more collective right state. And so I'd like to give Robert an opportunity to talk about that, because he's way further than any of us on how this works musically. And I'm sorry, Richard here.
So sorry. Yes, I've worked with systems that use phase lock loop, and this is in electronic music, and it's utterly fascinating. Actually, in music or in electronic music, it's more interesting to get stuff on the edge of chaos, basically, because that's where the surprises happen. So phase lock loop is actually a system that was maybe not invented, but first used in radio technology. And this was for the tuner, the receiver, to lock the frequency to the frequency of the sender, the station. So getting it close, you would get a signal, but there would be interference or destabilizing, all kinds of, again, musically speaking, interesting effects. But for proper reception, to get them really synced, like actually phase locked, so the phase is sort of the upslope of the signal, you get better reception.
Constructive interference, right?
But sorry?
Constructive interference.
Well, yeah, when they're not locked, then you get sort of just like a music instrument that's out of tune with another one, and then you start hearing the difference in frequency. But
The
the
beats.
difference in frequency you perceive as a beat. It's sort of like the volume goes up and down depending on how much the frequency differs. What I was getting at with the phase lock, so there's a sort of a, yeah, sometimes they use master and slave, but it's sort of like the leader and the follower equally problematic. But anyway, when the oscillator that syncs to the leader, it might be off just a tad, and then it gets synced, but then there's a tension between what its natural state is, a certain frequency, and now getting locked. So there's a tension, and I think that's everywhere, like in our own bodies.
Yeah.
Like as I see it, like evolution happened in layers, like it's a layered cake, and each layer gets figured out first before it gets applied. But once it's applied, it's integrated. It's an integrated whole.
Well,
But each of these,
like our cells must have their resonance that then sums
yeah,
in tissues, and the tissues have their resonance that sums in the organs, and the organs have their resonance that sums in the
yes.
body, right?
So these are all layers of organizational principles, but they get figured out in the quantum world first before they appear in the classical world. So the classical world is the whole cake except for the layer that we're currently uncovering. So our confusion stems from the fact that we haven't finished uncovering this whole layer yet. So we're both a Kantian whole plus an extra bit that's confusing us. They all.
I really like that. That's a great.
And this is a process. The closer we get to solving the puzzle, the more confused we can get. Like it's at least from my perspective, it's a challenge, and it takes maybe 1,000,000 years or more to get this solved. So that's where DNA and inheritance plays a role to bridge that gap from a limited life that each of us has and 1,000,000 years that needs to be bridged to solve this puzzle. But the puzzle as it's been solved gets carried on forward. So I inherit whatever my ancestors solved. And there's going to be environment involved as well, because the environment that you grow up in will have an effect as well.
Yeah.
So it's not just what you get in hardware, but in the environment as well. But anyway, it's I'm diverging from the face locking.
That's incredible. Yeah. Yeah,
But-
we're almost out of time here, guys, and I want to leave 1 minute. Henry, you have your hand up, and Josh,
Yeah,
you wanted to say
I just want to clarify, because I'm not against Charlie's idea. So in fact, I had some communication limited with Bill about the importance of the congregation selection. I actually, in principle, I really appreciate this kind of idea. But what I am very interested in is we're actually mapping back all the evolutionary theory in the history, and back to the history of evolution. It's quite fascinating. You can feel that, where it turns out actually Darwin is on the artificial selection. It's completely have nothing to do with all of this, right? So because of that, I'm very interested about in past few years about where to map the cognition in terms of the large scale, because we know the cognition is evolving. We know that learning capabilities fundamentally transition during this process. So the capability of cognition also need inheritance as a such complete way as the interaction. So that's why I rather than just simply say we want to use the cognition to replace the role of inheritance, but rather than develop is much more holistic, the so-called the ecosystem as a package of involved, and the soul is the information complexity themselves, right? So therefore evolution is directional. Maybe even without the cognition, initially cognition is very limited. Now we actually understand right now, maybe after a few years, the truly evolution, human intelligence, median evolution just beginning. So that time, I think, the Charlie, you use this idea. Initially, we can trace back from Karl Popper. They all involve lots of human, the realistic of the knowledge, how to use this to reflection on the subject. So that's the thing I'm not really satisfied as such. But if you get out of this one, so you have more realist to thinking how the cognition gradually evolve. We're actually talking about the mutual selection, right? During the mutual selection, initially bacteria cannot do that much work. They just by the very basic reflection, physical, chemical. And then gradually animals that have selection, they have sexual selection, they're actually taking in shape, right? Even human, we actually prediction always wrong. We don't have this freedom to really predict, right? So we think in the future, that's really cognition driving fundamentally direction of evolution. So in that sense, so that's what I'm coming from to talking about this. And lastly is because we have lots of idea, we thinking neo-Darwinian is wrong. So we have this idea. But if they fix that part, right? So then your argument, lots of argument disappeared, right? So in that case, what we need to focus on the problem, real problem, rather than the mistake of this, the previous theory. So that's what I'm saying. I hope the Charlie, you got my idea. I enjoy to read this one and to think your stuff, but I just want to precisely what's real in the history. For example, we know because bacterial cognition is extremely limited, right? So now, like the Chicago group, they said, oh, even the phase transition, the physics, the seminar like the literature. Yes, the all seminar. That's confusing always in biology. For example, in the cancer, people always use landscape model, they're similar, but they have totally have nothing to do with each other because cancer is not a developmental issue. Even though they have similarities, similar looks like a development, right? But they're different because that is a macroevolution issue. So in this conclusion, they also respond, but whether or not this response is truly kind of self-directed, we don't know. But now with the human, with the animal, we know that's the case. So if you mapping back of this degree of the conclusion, you realize that maybe there are difference. So themselves is evolving, right? So therefore, we understand which stage they inject, what type of conclusion. So that's maybe in the future, we really need to define how limited the conclusions they are and how freely they are and the capability, how they actually magically evolve and totally change the direction of evolution. Anyway, so that's what we actually have been working on that for a while.
Totally. Josh, did that cover what you were trying to cover, or?
I think there's maybe more to mine there, but that was great. Thank you so much, Henry.
It's a lot to mine there. Yeah, totally. Yeah. I mean, I think of it as this tension between inheritance and cognition. I think they're like incompatibly in tension. And we didn't get into senescence, but that's.
We dropped that part. I've got to go, everybody. Thank you so much, and see you next month.
Thank you.
Okay.
Everyone.
Hi,
Yeah.
Bill. Bye.
Yeah, guys. Thanks. Thank you, Yagana. I hope you enjoyed it. It was your first full meeting, and just wanted to welcome you. So.
Yeah, thank you so much. Yeah, I'm really new to this field, so whenever I'm listening, so like to the I have participated before, but not the full meeting. Whenever I join, yeah, I learn a lot, and it's just I look at these like topics from a totally different point of view. I'm coming from a synthetic biology like background, so it's totally different and interesting.
Yeah, well,
Thank you.
Awesome.
Thank you so much.
Yeah,
all right, guys. Well,
so before you go, Robert, I have quick. You sorry.
Yeah, stay on. Yeah, no, I've got.
So when you're talking about the different layer, right, they always build up. We actually thinking the biological. So that's another point we actually slightly different from some of our colleagues because we thinking that different layer have the different law. So the biological, the completely. So we do not. So you do not need to worry about the quantum physics about it because we actually realize, for example, in biology, this domain, they're not just follow the law, they create the physical law. So that's what we actually get so exciting about it. So they actually create the law, they're not just follow the law because they're a biological system. So therefore the information use the biological system as a package and constantly create the new law for the complexity, right? Mm-hmm. So now we never, when the people talking about the quantum, twinkling, all this to explain brain, we know they're in the wrong direction because this is totally
maybe I was confused about this as well. So chemistry would be the second layer interacting with the first layer. The first layer was quantum mechanical because there wasn't anything else yet there, not even space-time. Time there was because the process involved is recursive distinctioning. I think Richard was getting towards that as well. He didn't call it recursive distinctioning, but it's you have differences, and then you start noticing the difference, and then the difference itself between these two becomes a new element. So if in music you can have an interval like an octave, which is the most harmonious interval there is. And then when you play a quint at the same time, you actually get a chord for free, because it's the quint is the relationship between the one, and the quint is a relationship of 1.5, but the octave is 2. But then the difference between the octave and the quint is a chord. So although you only add one extra tone, you actually get 2 intervals. So now if you add the chord to this set, you get another interval between the chord and the quint. And this is recursive distinctioning. So then when you add that new interval to the set, you find more intervals. And this is a never-ending process. So this is what's called recursive distinctioning. And it was Louis Kaufman and Joel Isaacson, who published about recursive distinctioning, but they didn't include boundaries. So
Sure.
when you have a system, you need boundaries. Without boundaries, you have no system. So in music, an octave is actually a boundary. And all octaves are basically the same.
So,
Like
so
the interval stays the same. So if you won't know one octave, you know them all. And then you can sort of view these octaves as being superposed upon each other. So you might go and play in a different octave, but you can also reflect it back to an original octave, meaning that wherever you are, you can still fit it within this one octave, and then all of a sudden a lot more relationships become apparent. But going back to the recursive distinctioning, each layer is doing that. It starts out, like I say, with the octave as the boundary, in which another relationship is placed within those boundaries. But unless this third element is exactly between the octave, which would be the square root of 2, nothing else would happen. So any other elements, if you view the octave as a circle, any other element on the circle would create a recursive distinctioning system.
Guys, I'm gonna have to go pick up my daughter from the school.
okay.
Yeah.
So
Um,
I wonder if I could put you guys in touch, or
yeah.
maybe I could connect the 4 of us by email. We can have a different
Hey.
meeting, because I'm really fascinated by recursive distinctioning too, and I think it's deeply like part of what we're looking for. You know,
That has to do with infinity, and there's these recursive distinctioning systems find a stage of maximum potential where, in effect, infinity isn't needed anymore. It has
represent
found,
something finite.
yeah,
Yes, Lehar has that too, as like this Clifford algebra thing, and I think maybe there's some like synergy between your ideas and his as well. So I would love to dive into that some more. Maybe we can.
yeah.
Maybe we could do
Oh,
that.
thanks, Charlie. This has been lovely.
you.
And
Yeah.
Robert, it's great to have a hit of your energy. It's been way too long. Thank
Thank
you.
you.
Yeah, well,
Lovely to
Kate,
meet you too, Henry.
thank you for adding so much energy, Kate. You've really been helping this thing blossom, so I really appreciate it.
Oh, there's lots more
Yeah,
to say. I love what you're doing, and I think if you can build the computational story down in the thermodynamic story. Robert, I want to quickly turn you on to Ted Jacobson. I want to send you a link because he has found a way of linking thermodynamics with gravity. And there's this beautiful thing called a Lorentz boost that is very much like the boundary. It requires the boundary you're talking about. So I will send you
okay,
a link to him.
cool. And then I really
thanks.
liked William's presentation there in between. Like he seems really on the ball as well.
I've
Yeah.
got to get his book. I've
Yeah,
seen his
yeah.
papers and I love it.
It's a great
Yeah.
book. Yeah, thank you so much.
Charlie, thank you so much.
All right, guys. Okay, see you soon.
Bye,
That
Henry.
daughter a
Hope
hug,
we
huh?
can connect.
Totally.
Okay, bye.
All right.
Bye, Catherine.